Good morning, all.
Good morning.
Hey, Mel, how you doing?
Hi, I'm good. How are you?
Good, thanks. Just try and log in here. Morning, Ender.
Good morning, Ellen. How are you?
I'm good, thanks. And you?
I'm good, thank you.
Okay. Howard. Good morning, Howard.
Good morning, everybody.
Good morning.
Okay, Howard, you've not been to this main meeting before, just the interconnect workstream one, right?
Say that again.
You've not been to this main meeting of ours. You've just been to the interconnect one. I don't seem to have a record of you in the main one.
Yeah, usually I just go to the connector one because really that's what I care about.
Yeah. All right, that's good. All right,
But
well, welcome to this one.
sometimes having a little more background helps.
Yeah. Good morning, Michael. Good morning, Kevin.
Morning. Morning, Alan. Good morning, everybody.
I've learned how to read barcode, Kevin Cameron.
It's for people who are bored. You can go scan it.
Morning, Andrew. Morning, Matt.
Hey, Alan, good morning.
Good morning.
Good morning.
Morning, Jason.
Hey, good morning, Ada. Hey.
Morning, Majid. Who am I missing? I'll give it a couple more minutes till 8:05. The last stragglers. Yeah, Mitch, I just replied to your question. So the mailing list is where you can get a calendar invite.
Great, thanks. Do you have a link to it by any chance?
Yeah, Lauren, let me just.
Because I went poking around on the webpage and I couldn't find it.
So it's under the get involved. Let me just do the. Okay, so there is the mailing list. And if in the mailing list, if you're registered, which I for this on the mailing list, then you should be able to see the calendar. And then you go to the calendar and you can download the series.
Okay, thanks.
Let me know if you have a problem. Morning, Jeffrey.
Good morning, sir.
Okay, I think we'll get started. Let me just do all the attendees I've captured so far.
Is there a die-to-die call today too, or for white benchmarking?
I'm not sure. That's on the ODSA, right?
Right.
Yeah, I'm not tracking that one actually. I typically just go to the main.
Right. Okay. All right. Thanks.
Just putting things out, right? Okay. Right, well, morning, everybody. I welcome to the OCP High Performance Compute Subproject main meeting. Today I wanted to just give a little bit of an overview on some of the progress on the work streams. But there was a couple of other things that just also popped into my mind. We have the regional summit coming up in Portugal, in Lisbon, and we do have a little presentation slot there. So I'll just touch on that and in what we're covering there. And I might need a little bit of help with some of that from some of you specialists. So we'll cover that. Then I was really quite pleased in the fact that we've sort of been taking a little bit of a step back, I guess. For those of you that don't know, the Oak Ridge National Labs DOE New Frontiers RFP is actually been put on hold. I'm under the impression that it's been put on hold because of continuing resolution or something like that, or that was what I heard firsthand. But we got an official notification from the DOE or from Oak Ridge National Labs that that it was on hold until further notice. I don't think there's any concern it's going to be cancelled. In fact, I heard somebody saying they may well be upping the actual budget from the 23 million as well. So so that gives, as I've said before, that gives, the good news is it gives us a little bit more time. The bad news is it moves the deadline. So without a deadline, you know, it doesn't focus the efforts. But so we've in the free work groups, we've had some more wandering discussions, which I think have actually been very productive. So I just want to give you a quick update on each of those. And also just on the HPCM module itself, you know, which ones do we move forward with, and how do we convince various other vendors of silicon accelerators to actually make an HPCM module? We've always said in the past that an FPGA one would make first sense, make good sense as the first module to build, and it's something that I have a long history in anyway. So we'll touch a little bit more on that as well in terms of an application area specifically of the ASIC emulation space with FPGAs. So we'll cover that. So I don't believe there's any new members on this call. I guess Howard's not new because he attends the interconnect. Maybe Howard, just for the benefit of people that don't attend the interconnect call, you'd like to just give a very brief intro of yourself.
Mute. I connector guy for forever. And very recently 20 years with TE, and now just for the next year or so with Lotes. We'll see how that goes. Basically worked on sliver connector, power connectors for OCP, card edge connectors going back to the dark ages. So really I'm on this call just to get a little more background in application and that sort of thing. So yeah, located in Harrisburg, Pennsylvania.
Okay, great. Well, welcome, Howard, and thanks for your contributions to the work, to the interconnect work stream. Okay, I don't believe anyone else is new on this call. Shout if I've missed you. Oh, okay, great. Yeah, so first let's cover the OCP regional summits. So we actually had a couple of entries. Munir from Lattice put in an abstract for the system management side of what we're up to, and I put in basically the regular update to these OCP conferences of what we're up to here, and I titled it Progress Towards an Open and Sustainable Energy-Centric Computing Architecture for Today's AI and HPC Applications. But what I've done to be a little bit different, rather than going over the, you know, people can refer to the presentation I gave back in October, which I think is still pretty relevant in terms of getting a good all-round high-level overview of what we're up to. So I thought I'd take this opportunity to dive into a bit more details on what we're trying to achieve on in the power and thermal infrastructure area, because that's we're making some pretty radical changes there. And also on this idea of this universal interconnect of being able to move from a world of, you know, the world of electrical copper interconnects to the future of everything going optically interconnected, and how do we make that transition rather than this what appears to be decades worth of effort of a binary step between copper and co-packaged optics, or even in silicon optics was the first attempt, and then it went to co-packaged. So I think there's plenty of space for this migration between the two worlds, and I think it warrants a really close inspection of trying to make a universal interconnect. And it's as well, if you look at all of these different fabrics that are coming out, proprietary runs as well as extensions to existing ones, there is a great deal of them, and we want to be able to support all of them with this Lego block approach and be able to do that. So those are the two areas. I'm going to give a very brief over. It's only a 15-minute presentation, but I'm going to give a very brief overview of the module itself, the overall architecture, and refer people back to previous presentations on that, and then try and put a bit more meat on the bone of the power firmware in the universal interconnect. So now I need to get a draft presentation in by March the 18th, and the conference is I think it's April the 24th and 25th. So we've got a little bit of time. So I'll be working on that, and the progress we are making in these two areas in the work streams. I've got some material to get going, and it is only 15 minutes, but might leverage some effort from you guys if that's okay, to help if I need some technical meat to put into that presentation. So that's the OCP Regional Summit. Any questions on that? Okay. So the next topic was, I was going to go through the work streams, just give you a brief update on the work streams. And anybody on the interconnect group here? Oh, sorry, I haven't. Am I sharing my screen? I'm not sharing my screen. Apologies, guys. I thought I was sharing my screen. Okay, can you see that?
Yeah.
Yeah, so that was what I thought I was sharing the the abstract from the regional summit. So there it is there. Yeah, so going through the three different work streams. The first one to give you an update on is the universal interconnect work stream. And like I said, anybody just feel free to jump in. Just a minute, I think we've had a few more participants join. So hi, all the new ones. Hi, Manir. Hi, Trent. Let me just capture.
What are you sharing, Alan?
Just the
We see your email, I think.
Oh, are you?
No, I see the file that said contact hours.
Oh, really? Oops. Desktop one. Share. Are you seeing the OCP project document now?
Now it's a good one.
I think that's what you meant to share.
Yeah, and could you zoom in, maximize?
Yeah, it's very small and there's a lot of white space, but beyond that, I think this is what you meant to share.
Sorry, guys. Yeah, thank you for that. And please ignore what you saw. Okay. Yeah, so is that better?
Yes.
All right. So let me just capture the new attendees. So Trent. Hi, Mr. Hartke. Hi, welcome. It's been a while. Okay. Manira.
Yeah, I can hear you.
Yeah. Okay. Yeah, I'm just capturing you all. That's all the extras.
Sure.
Great. All right. So yeah, onto the interconnect. So as I was saying, we want this interconnect to be a universal interconnect that can really have the potential to take us from the copper world we live in today to active copper cables, to active optical cables, near packaged optics, that is, and co-packaged optics. That would be the ultimate vision, supporting any protocol. So again, the whole idea of this approach is that we're covering the mechanical and the electrical specifications of this universal interconnect that allows us to be able to support all the different formats that we see today. So, you know, PCI and CXL, Ethernet, NVLink, Infinity Fabric, UPI, SMP, a bunch of custom ones from a bunch of startups like Grok are hitting the news a lot now. They have their own custom interconnect. So being able to support any type of interconnect with this one universal cabling. And the idea here is that obviously when you know, we have very much a step and repeat Lego brick architecture here where we can cable anything to anything. But rather than keying things, they all fundamentally use the similar transceivers. So the idea would be that the system management part of the equation would actually discover the networks that were connected, and if a incompatible link was wired, like NVLink to Ethernet, it would report that issue before even turning the modules on. So you know, you're thinking about that in a different way. And or another example, if you had Infinity Fabric connecting to PCIe, Infinity Fabric often can actually train down to a PCIe or CXL connection. And so you can then also manage going into compatibility modes if you've got a link going between two where there is a compatible mode of operation. So that's the thinking on the universal interconnect. And like I said, I think we're all on our way to optics and the co-package. We got the promise of co-packaged optics. There are some serious things I think we need to think about. And I've talked to various of the silicon photonics companies about the potential to bring the optics out the bottom rather than the top or the side. And fundamentally, it sounds like it's doable. But whether we'll be able to change that world, I don't know. And obviously, working with Avicenna, and Mel's on the call, she's kindly given me a 3D model of their LED optics. And you know, I've shown some models. We've played about with some models of how we could go from co-packaged with theirs to near packaged options as well. And just one last thing, really, on this as well. If we look at what we're doing, we've got major thermal densities with these processors now. There's talk now that NVIDIA's next device is going to hit 1 kilowatt. I saw in the public news just a couple of days ago, and you know, and look how small everything is there. And then we've got QSFP cages struggling to cool some of these new 1.6 terabit optics, and you know, traditional optics as opposed to silicon photonics. And we're seeing that we're moving to OSFP cage sizes to be able to cope with all of this. You know, so we're getting bigger in the cages for just a couple of tens of watts. And you think, well, if you put that, an SXM module from NVIDIA would be the size of a 19-inch rack if we were at a thermal density of a QSFP or an OSFP. I think we can do a lot there. And my main point is with the optical technology from the likes of Avicenna and the silicon photonics people, I've seen Lightelligence had their actual circuits, their silicon, etc. Is actually so tiny, it's just rattling around in these QSFP cages. So we can pack it into the cable sizes that we're looking into this universal interconnect. We do need to look at water cooling of that, you know, to keep that density up for maybe 5 to 10 watts of power or so. So again, we're covering all of these bases, and the one thing about these 3 work streams is I think if we can get this packaged nicely between us and the collaboration, they look extremely nice. If I'm the government looking at this and saying that this is a good innovation of trying to get the industry to rally around, pulling all of the things that have moved on, which have been evolutionary, but trying to do a little bit of a clean approach to this, and this would be quite attractive. So again, the idea in this proposal is that we can get each one of these standalone in the proposal itself. If we can put the numbers together with each section, the government might say, well, we particularly like that one, and we would like to fund that, but we don't want to fund all of it, or something like that. So we do have maybe a couple of shots at getting some sort of funding to move the puck forward with this effort.
Alan, sorry,
yeah.
a quick comment or something. Another work stream that maybe is more limited is this PCIe extended connectivity that has active electrical optical cables in it.
Yes.
Yeah, so that's kind of maybe a small predecessor to this work.
You mean PCI SIG?
Yeah.
Yeah.
No,
so
not OCP one. The one that I think.
Yes. Oh yeah, right. So the OCP,
Mohammed, someone, I think Astrolab and somebody else.
Yes.
Meta,
Yes.
yeah.
No, so thank you for that, actually bringing that one up. So the PCI SIG is actually standardizing on something that's been around for a long time called CDFP.
Right.
And it was an effort between Molex and TE many years ago to do PCIe, but it's natively a by 16. I think there may be some efforts to make it bifurcatable into dual by 8. But fundamentally, they've gone with that, and you can put active componentry in there to make it optical. But to your point, there was a debate around CDFP versus using QSFP DD where it's 8 lanes. And OCP has been driving in that direction, and the likes of Astera Labs, etc. So yes, so the stuff that's going on, which is great. Again, this is what they're doing is what the industry needs and expects, and it's a nice shoeing. But it's not looking at everything holistically, which is what we're trying to do from a clean sheet, obviously. So, but yeah, that's a very, very good point. So thanks for making that.
No problem.
Majid. Any other comments on the interconnect? Just one other point I would make as well is we've had some discussions. We're looking at the 3D models. We had some discussions around paddle card versus no paddle card in terms of the cables, like the MCIO is the industry standard one from PCI SIG that Amphenol have put together, and it's licensed to everybody. But there are some direct cable ones from Samtec and Molex. And just from a passive cable signal integrity, I quite like those ones, but everyone agreed that a paddle card would work. We did look at some paddle card options for the wire connects, which were quite interesting, but these are proprietary connectors. And I think some of the right angle release. So I think we need to analyze the number of bends you go through anyway, without getting into too many details. I think we probably are concluding that maybe we move with the MCIO, which is obviously already well adopted in PCI SIG as the physical sort of basis, and it's a paddle card based for this interconnect, but we'll change the pin out slightly to bring power and also we don't need as many pins. We need about 66 pins at the moment, if I remember rightly, compared to the 74 of the standard MCIO. So we'll probably do some different keying on that as the sort of the mechanical basis is where I think we've got to through the various discussions with the various interconnect companies. So
there is one more activity I think the collaboration between PCI SIG and SNIA
Yes.
and around the external internal cable, both and also even the optical cable, that's a new subgroup. So those are also linked here.
Yeah, they are.
Especially the SNIA new standards, new specs.
They are, and so that one is they've extended it to bring power. So sadly, they've to bring power onto the MCIO. So it's a slightly bigger connector. And
well, especially also some of these Flex IO, they call it, whatever that they have defined.
Yeah, but obviously all of this is they're geared entirely to PCI. So they're geared entirely to just PCI, right, and CXL.
Right.
Whereas that we're trying to cover everything. So is the idea. So maybe we can leverage from what they've got. They're doing.
Well, it has to be something superset, because even there, they're saying, okay, we have to sort of leverage, Ethernet and other cable and connector and cage and other.
Oh, excellent. Oh well,
yeah.
well, maybe we can align the efforts. That would be a bad idea for sure.
Right.
The only thing is I felt that they were growing. We could actually make the connectors smaller if I didn't want to spend additional money, so I thought leveraging, starting with the MCIO or one of the other connectors like from Samtec or Molex was a better way to go, but maybe just keying them differently because all of the universal features we might bring into it. But yeah, for sure, it would be worth potentially folding it into some of those efforts, and we would definitely need to line up with SNIA, etc. at some point. So
Right.
yeah,
Thanks. Yeah.
Good point. Yeah. Okay. So that that's quite an exciting one from my mind. If we can do this, and I think that there could be some good interest in that. On the thermal management work stream, we've had a lot of very good discussions. Boyd, as ever, have been fantastic, as they have been over the last 2 or 3 years, in helping us with the intelligence. And those of you that have been here have seen numerous updates on our approach to the thermal to try and deal with the ever increasing power demands. The latest ones from Boyd were it's getting crazy because they're now designing up to multi-kilowatts, and I guess that's an interesting question, is whether we want to go all the way to that level or not. But they're needing very tight chambers where they want 40 psi of pressure to be able to cool this. So without getting into the technical details. Whereas we've been sort of looking at some of these novel ideas, like the University of Illinois conformal coating of an insulation layer and then a copper layer, and then using water, which is maybe a little bit more radical. And also we've had discussions, I don't believe Peter's on this call, but we've also had some discussions around which came from OCP regional summit last year. That's where the idea originally came from me, is actually by pulling a vacuum, we can actually make water boil at a lower temperature, like at 65 C. And apparently that would be 7 times more efficient at pulling heat than just the water by itself. And water is far more efficient in these dielectrics that are used in immersion cooling. And so, but obviously none of this is as efficient as copper for moving thermal mass. So we're still looking at this immersion. So we're looking at this little immersion chamber, but equally, what I'm also thinking is things like the FPGAs, etc. We can be in the 200 to 400 or 500 watt range quite easily with a lot of people's accelerators. And so a more traditional copper copper heatsink could also come in. So I was thinking that maybe we can have a little bit of a bit of a universal thermal where we could potentially migrate towards these little micro immersion chambers from more traditional copper attached heat sinks with water flowing through them. And again, so we have that migration path and see if we can innovate. And by using water, environmentally friendliness of water and the small amount that we're using, it's all very good for the sustainability aspect. So again, it feels like quite an exciting direction that maybe isn't being pulled because, there's other ways of doing it without breaking the way that's been done so far. People keep improving on those approaches. So I think we've got some interesting discussions. So we've talked about how we would do the thermal loop to pull the vacuum and to pump the coolant with the modules, and have the modules have their own control valves for making sure they always eject 65 degrees C water, or water of a certain temperature. And how would all that work? It would be quite a complex control system in terms of the actual water management itself. So trying to get a little bit more innovative there on what we could do by on that side. So and I'm talking to some experts in that area as well. We're looking at some modelling that we could potentially do and hopefully get before the presentation in Portugal. So that's an interesting area. I'm not sure if anyone's on the thermal side. Is there any other comments or questions on that?
Have you looked at like heat pipes and like materials that boil at lower temperatures like alcohol?
Well, apart from the fact of using those normal approaches that are obviously used in heat sinks traditionally, but no, we've not looked there in this particular one, though.
Yeah.
I mean, obviously that is a possibility as well.
The thing with water is water's got a very high specific heat capacity, which makes it good for some of this stuff. But I mean, mostly phase changes will absorb an awful lot of energy. That's why if you take your water and put it under a vacuum, it will boil at a lower temperature, but then you're kind of losing your vacuum as it boils. So it can be better to just pick something that boils at the temperature you want.
Right. Okay. Well, that's where we need the expertise.
If you pick an alcohol, pick something that's not actually electrically conductive. You probably have fewer problems if it leaks.
Yeah, but then this is the environmental friendliness of it and the rest. But yeah, if a vapor chamber is very much a possible combination. I don't know. But that's where I think we have this clean sheet of paper and we can look at it from the ground up. So that's the idea. So those discussions are going on. I mean, if you have that expertise and you have the modeling tools to do it, Kevin, come and join us.
Alan,
Yeah.
Not that I have the expertise in this area, but we run into tons of problems where water cooling, when it's just pure water, will eventually grow, and you are ending up back flushing and it's just a mess.
All right.
When you're saying water, is it pure water, or are you going to have some sort of
I was assuming possibly some sort of
or something?
Yeah, some sort of treatment of it, I guess, some minimalist treatment that stops the.
We have not. It sounds like you've talked to Oak Ridge quite a bit. You should see if they've published any of their papers in the disaster that was Frontier.
Okay. Interesting. Okay. All right. Thanks, Trent.
Pure water is not a good idea, even with some amount of treatment.
Okay. Interesting. I also heard, and again, no expertise here, that I heard that obviously, depending on the materials you use with the water, will make things a lot worse or a lot better, or mixing materials. So I don't know how much that features in any of
Yeah,
that.
it absolutely does.
Right. So again, I mean, yeah, we know enough to be dangerous, but we're also stupid enough to to start from scratch and try again. But to learn from all these other ones without making the same mistakes would be a nice place to be, for sure. So okay, well, thanks for that. I'll actually dig up the and if you can point me in the right direction, Trent, that'll be great on the Oak Ridge Frontier stuff.
Okay, I'll see what I can dig up that's public.
All right, thanks. So that's the thermal one. So again, at least we're just exploring different ways that of doing this, which may we may come across as idiots in this, but I don't mind that. If people that know what they're doing tell us why not. But equally, often people that have their current solution are blind to the potential of a new approach. So anyway, so that I'm really quite pleased by and we've got good collaboration going on in these work streams. So you know, it's not just me talking for a change. Then the next one was system management. So I'm really liking what's going on there. We started with the hardware aspects, where we really want to try and think about the system management is more of a holistic control plane rather than this 1970s patchwork quilt of I2C rubbish. Although we still need that legacy support, and obviously with root of trust and security being, you know, top of mind, and this has been a horrible backdoor entry for hackers, etc. You know, this is being worked on heavily already in OCP, with like the DC SCM, the security control module, and we want to be part of that ecosystem for sure. We've got obviously OpenBMC seems to be the software side being opened. Everything's built on top of this Redfish. But one of the things that in HPC has always happened is it seems to be like a brand new machine. Every rip and replace of a new machine also means the poor old guys in the labs have to start from scratch with the system management software each time, because there is no coordination there. So bringing that to be a much more of an open standard would be good. And we've got John Lung from Intel is great. He is the wise one with all of the historic standards. He knows everything that's going on in OpenBMC, Redfish, and all of that, and making sure that everybody is suitably trained on what is available today. And then we've got Alex Lovell-Troy, who was a ex-HP, but he's now with LANO, Los Alamos National Labs, and his entire focus is on an open standard system management software approach, which you can use. And he's got actively funded efforts already going on there, and there is some open standards body that he's working with as well. It was set up a couple of years ago, I believe. So that's good. So we can pull him in. And finally, a relatively new member of ours that's on the call now, Jeffrey Mershon from Unify Point, is bringing an even higher level perspective of how do you maintain these 10,000 node machines or 100,000 node machines without having 1,000 IT staff. And apparently he was saying that Google already do some crazy numbers of crazy few IT people, like 1 per 10, 20,000 or whatever it is, servers.
Per 45,000 machines.
1 person per 45,000 machines. And Google do it for themselves. And his startup is basically offering similar services in this preventative maintenance, monitoring everything, and then knowing when things go wrong and actually, or things are likely to go wrong, and actually reporting that. So those 3 layers, between the 3 of them, I think that we've got quite an attractive grounds up. Again, want this to be as open source as possible, thinking that we can get a good system management approach. And on a hardware level, we're going to FPGA based. So Lattice, Monero, who's on the call, we're driving an FPGA base, which is called Libra BMC. It's again, from a security perspective, it's being open source from the ground up, so that we know all of the code base behind the hardware as well as the code base behind the software from a security perspective. So we're doing that. And finally, one other piece I'm trying to get into this with some interesting thinking with optical, free airspace optics between the modules, would be a control plane through the system for the system management, running at a decent rate, so that we can get good telemetry out of these modules, and good monitoring of power, etc. And also intelligence up into the software of the likes of Jeff's company, so that they can make even better preventative decisions. So that's an exciting one as well. So I think we've got a section for each of those in this platform. So any questions on the system management or comments? Okay. So these are three sort of separate focus areas, and then we try to bring it all together in a systems integration system approach. And if we could have one system integrator, that would be good. We've got a startup called Teresa that's interested. We did have a company called Iabra, but they seem to have lost a little bit of steam in terms of their interest in helping this. So Teresa, but they're a startup. They're looking for funding, but they potentially have the desire of the whole system coming together. Also, I've got some interest from Bob Ciotti was interested. He was a NASA CTO and very interested in this. He's now working for a company that's a value-added reseller into the labs. So they've got all the experience of the commercial details of how to work with these labs. So potentially they could help out. But these are all sorts of tentative conversations at the moment. There's other ones. Teresa is also working with some bigger, more well-known system integrators in terms of would they be like to front this proposal as well. So we're still a little bit shaky on the system integration side. So if anybody knows anybody who would be interested in helping out on that side, that would be good. But like I said, I still think these three different sub efforts warrant potential funding from the government, and well, we'll find out when we put the application in. Turning to the HPCM modules themselves, we've obviously got a bunch of HPCM modules we'd all love to do, but the FPGA one has always made sense. And just to give you a little bit of a story, so those of you that don't know, my background is heterogeneous computing architectures from the 80s and 90s, where we actually discovered the FPGA for compute. And so my company, I guess I'm known as a pioneer in the FPGA computing space. And in the early days of our company, we accidentally stumbled into a 25% of our business, of our revenue, came from ASIC emulation. Now, it wasn't big revenue at the time, don't get too excited, but basically we had FPGA cards where we had 7 of the biggest FPGAs on a PCI card in the early 2000s. And companies, ASIC companies, design companies would come and buy our cards, and they were big purchases, right, for us. And it was like, why are these guys buying these cards? And when we asked them, they said, well, our other choices is an aptX box or a QuickTurn emulation box. They were the ones of the day. But these are big, expensive boxes with lots of layers of, how to connect these FPGAs together and make it disappear from your ASIC you're trying to emulate. But they charge an absolute fortune for it. And we can buy your card and we can sort of do our own homegrown ASIC emulation on the FPGAs with your card with 7 of them on. And so that was a nice little business. Well, there's 2 other things. Because I'm from this area, I'm actually seeing a demand for ASIC emulation. Obviously that's an acceleration. Really, we're accelerating simulation of new ASIC designs, and these new ASIC designs are huge, right? So you need these huge ASIC emulation engines. But all of these ASIC emulation companies have now been absorbed into the big boys, Synopsys, Cadence, and Mentor, I guess, or Siemens as it is, have their own platforms that they've acquired over the years. And I think they provide them as a service rather than sell the machines. I don't know to be perfectly honest. But I get the impression it's an extremely expensive game to go with the rest of the expensive ASIC development. And so I've seen a number of companies say, we're going to build our own ASIC emulation platform. Do you know anybody that can provide the FPGAs? Or, you know, so it's a case of, now obviously they need to connect lots of FPGAs together. And so with lots of interconnect like we have on the HPCM, and Xilinx have a dedicated device, the VP1902, correct me if I'm wrong, Paul, is their biggest, baddest one, specifically targeting the ASIC emulation market with about with a good number of transceivers. I think 160 transceivers on board that we can bring out to this on our module on the HPCM. So I think that we would make quite an interesting, low cost, very scalable ASIC emulation platform. Now, to add to that, I've been heavily involved in the ODSA chiplet workstream, more as a listener and often a heckler, I guess. And if you look at what's going on in the chiplet world, it's you know, obviously dicing up maybe traditionally monolithic die into multiple chiplets, or having heterogeneous chiplets that you connect together with these chiplet buses. But there's a big challenge. There's a bunch of business and technical challenges of getting an industry standard where we can all play in this chiplet world, versus the big guys just doing it for themselves. And, you know, so therefore keeping it as simple as they can is that they provide all of the different chiplet dies. So what struck me is, and I'm an organic business guy in terms of the way I started my original company, Nalitech, is we need some sort of organic approach to get the chiplet community going. And simulation, if you're simulation, you know, you get the simulation engines from the various vendors. And if you think today, without getting into too much detail, if you think today, if you're making your own monolithic chip, you still buy virtual chiplets, like you'll buy a PCI core from Synopsys, you know, and you buy a bunch of library pieces, and you jigsaw them together in your monolithic die, and they have simulations for them, and you simulate your entire chip, and you maybe even emulate it, and then you're off, you know, and then you spend the big money on building your ASIC. Well, in this chiplet world, you can still do that same simulation, but also if you do an emulation, you can do an emulation of the entire chip, like the entire family of like 5 or 10 chiplets, let's say. But you might be buying a couple of off-the-shelf chiplets to start with that already exist, and you might be making a few of your own, and maybe a few of your partners might be developing some for you as well. So you would ideally have this one software simulation of the entire chip, and then you'd want to make a full emulation of it. So you'd get the emulation files from the various vendors. And so you would plug all your chiplets together in this emulation environment with even an emulation of the chiplet interface, like a bunch of wires or UCIe. And but then so another thing I used to do in my military world was we would actually test defense systems. And so we would actually plug our simulators of generating simulated targets into the machine, into the defense system, and fire real missiles against our simulated targets. So we called that hardware in the loop. Or when we're making a certain missile system, you'd have a simulation of the whole thing, but as a real piece of hardware came to be, you would replace that in the simulation with the real hardware, but keep the simulation of everything else. So what struck me is we could do this with this HPCM approach, is as you get real chiplets, you could introduce a real chiplet into your emulation platform. And hey, Majid, can you go on mute? I'm talking. Yeah, so the idea would be that you could bring a real chiplet, and if you had an FPGA interface with the chiplet interface like bunch of wires or UCIe, you could potentially build an HPCM with some of these chiplets on and bring them into your emulation, bring the real hardware of the chiplet into your emulation platform. So it feels to me like it would be a great use case for us to help in the chiplet enablement world, as well as the bigger emulation world that other people are doing. So people often say, well, what's a good application for this new approach to hardware? And so I guess I'm feeling a bit more bullish that this, and we can do this with a single module, or potentially we might want a couple of modules. Maybe we want a second FPGA HPCM that has HBM on board, for example, because that seems to be a big feature of a lot of these devices these days. But at least at the very beginning, we start with the VP1902. Is the idea there. So that's that. Any comments or questions on that? No. Those people that are on the I don't know, the people that work in the chiplet group or attend the chiplet ones, the ODSA. I don't know if you've got any perspectives. Okay. So that basically covers everything I wanted to update everybody on. We've got any other business? Is there any other topics anyone would like to bring up? I mean, the only other thing I'd like to say is whilst the RFP is on hold at the moment, if we can start to make more progress in this overall document, that would be great. And so anybody that feels they can contribute would be good. And in these minutes, you'll see I've got the new frontiers, the current draft RFP that we're working from, and our current responses here. Okay. If there's no other comments or questions, we'll leave a couple of minutes early. Thanks, everybody.
Thank you. Bye.
That was great, Alan. Have a good one.
Thank you,
Have a good
Alan.
day.
Alan.
Thanks, Alan. I got the notice.
Oh, great. Good.
It worked.
Good.